Welcome to the very first video for Unit 9 over the history of gas laws. So before we go over each individual gas law, we need to discuss the variables that are observed in these gas laws. So you should already be familiar with each of these three terms, but just to make sure that we have their definitions down, you need to know that pressure is a force applied on a surface. Temperature is not about how hot or cold it is. Temperature, you need to change that in your head to about how fast the particles are moving. The higher the temperature, the more the particles are moving. And then obviously volume is the amount of space occupied by a substance. For each of these, they need to be in a particular unit whenever we're doing our calculations. So for pressure, it needs to be in a unit known as an atmosphere, which in short is ATM. And so if you are not given pressure in that right unit, you're going to have to convert it first. Temperature needs to be in what's known as Kelvin, or just a capital K. So if the temperature is given to you in Fahrenheit or Celsius, you're going to have to convert that out into Kelvin. And then volume needs to be in liters, so just a capital L. So in this video, we're going to go over three scientists that contributed to the study of gases. And the very first of those scientists was a man named Robert Boyle, and he did his study in 1662. And what he did was he observed the relationship between pressure and volume. And so you can see the formula for Boyle's law is P1 times V1 equals P2 times V2. That basically means the initial pressure times the initial volume equals the final pressure and the final volume. So that relationship between pressure and volume is known as an inverse relationship, meaning as pressure increases, the volume is going to decrease. So the graph is going to end up looking something like this. And so where this comes from is if you have a container with a certain amount of gas in that container, and so you've got gas particles that are floating around, and every time a gas particle bounces on the side of that container, that applies pressure. So every time this happens, you're applying pressure. We'll say you decrease that volume. Say you cut that down in half. You still have the same number of gas particles, but now they're occupying less space, meaning the chances of them hitting the side of that container is going to increase. And so as the volume went down, the pressure is going to go up because those gas particles are now going to hit the side of that container more often than when they did when the volume was larger. The next scientist in 1787 was a French scientist by the name of Jacques Charles, and this is the guy that whenever you see his name, you automatically need to think of balloons, because he studied balloons and the relationship between volume and temperature. So whenever you're talking about balloons and how they change size based on the temperature, you need to think of Charles. And so you can see the formula for this gas law is the initial volume divided by the initial temperature equals the final volume divided by the final temperature. And so the relationship between volume and temperature is actually known as a direct relationship. And so if you were to graph that, as temperature increases, volume is also going to increase. So it's just going to be a straight line going diagonally up. And so what does this actually mean? So if you have a balloon and you've got gas particles in that balloon, if you increase the temperature, what's going to happen now is that because those gas particles are moving around, remember you don't change the number of gas particles, but they are going to be moving around much quicker. Remember, temperature is about movement. So if you increase the temperature, you're going to increase the volume. Those gas particles are going to need to take up more space, and the reason they need to do that is because the pressure is going to remain the same. So in these gas laws, two variables change and one variable remains the same. The one that remains the same is the one that's left out of the formula. That's how I remember it. The final scientist in this video is a man known as Joseph G Lusak, and he did his research in 1822, and he studied the relationship between pressure and temperature. And so you can see the formula there is the initial pressure divided by the initial temperature equals the final pressure divided by the final temperature. And so just like Charles's law, these two variables have a direct relationship. As temperature increases, pressure is going to increase. And so again, if we were to draw that out, you have a container with gas particles. In that container, the volume is not going to change size. Volume is going to remain the same in this situation. And so what's going to happen is if we increase the temperature, you're increasing the movement of these particles. So why does the pressure increase? Well, remember that pressure is exerted by gases when they bounce off of a surface. So when the temperature is low, they are still going to bounce off the surface of this container, but if they move faster due to that increase in temperature, the pressure is going to go up. So because this video is very short and sweet, I want you to practice your summarizing skills. So make sure that you go over in your summary the variables that are in gas laws and briefly describe the name and the relationship for each gas law and what scientists contributed to that gas law.